last statements we're going to go over is a biconditional statement. In a biconditional statement, there's P implies Q and Q implies P. If you notice, this is the conjunction of a conditional and its converse. And symbols, a simpler way to write this is P and then a line with an arrow on each end, Q. And that's read as P if and only if Q, or P IFF, if and only if Q, which is meaning that P implies Q and Q implies P. Let's go over an example of a biconditional statement. So P is a statement that we won the soccer game, and Q is a statement that we scored more goals. So P implies Q is if we won the soccer game, then we scored more goals. Q implies P being that if we scored more goals, then we won the soccer game. We can see that both of these statements are true. If you win the soccer game, you score more goals, and if you score more goals, you won the game. So let's look at P if and only if Q, or the biconditional statement of the two. We won the soccer game if and only if we scored more goals. And this if and only if can also be abbreviated as IFF, if and only if. Let's look at a truth table for a biconditional statement. So here we have P, Q, P implies Q, Q implies P, and P implies Q, and Q implies P, which is also P if and only if Q. They mean the same thing. This is the biconditional. So let's fill in the truth values. P implies Q is true everywhere except when the true hypothesis implies a false conclusion. Q implies P is true everywhere except when a true hypothesis implies a false conclusion. And in order for the biconditional to be true, both the conditional and the converse must be true. So this is true, false, false, true. And these are the truth values for a biconditional statement.